Hi students, welcome to Alpha's e-learning program mathematics class. We are in trigonometry. The concept is periodicity. In previous session we have started that one, and yesterday, that means in previous session, we ended with a concept of the period of it is a constant function. Suppose students, if you take here f of x is equal to sin square x plus cos square x, understand, or f of x is equal to suppose sin square x plus cos to the power of 4x divided by cos square x plus sin to the power of 4x. Whenever you observe these type of functions, actually the domain is all the real numbers. So for all real numbers, actually these values they exist, understand. Even it is in denominator, 2 is there, 4 is there, even parts, and here plus symbol is there, therefore denominator not equal to 0 any time. Hence here students, you can observe these two functions, what are answers. This is equal to 1 and this one also here equal to 1, okay, and this is true for all x belonging to R. So this is a very important constant function undoubtedly, but for what values of x, that is important, and it is true for every real number, understand. And hence now what about here period of this kind of functions. This we have observed in previous sessions. The period is nothing but here it can be any value, it can be 1, 0.5, 0.3, whatever positive value you consider, it is period of this function. But what is the problem? Where the problem is existing here? The problem is nothing but here it is a constant function, so we are unable to decide the fundamental period, okay, because what is fundamental period? The least among all possible all periods, understand. Whatever the least among all the positive values, that is this value is our fundamental period. So in terms of constant functions, we are unable to decide about here the fundamental period, because the gap here you can take any kind of value, 0.001 you can take, 0.000001 you can take. So you cannot decide exactly what is that least positive value among all the periods. That's why here we said that constant functions are no doubt they are periodic, but fundamental period we are unable to decide when they are related to every real number, understand students. So the domain part is very important. Why I am stressing these many times about the domain part? Because let us consider here one more example, that is suppose if I take f of x is equal to secant square x minus tan square x, right, and you know clearly here this value is 1, no doubt at all. That doesn't mean you cannot decide fundamental period here is indeterminate, okay. Why so? Because observe students here, what is the domain? The domain is nothing but here tan, the denominator sin by cos, here 1 by cos. So you are having cos value in the denominator, implies this is true for all x belongs to all the real numbers except odd multiples of here pi by 2, right, and this is n belongs to integer. And now these kind of values only, for these kind of values only this exists, and that value you got here 1. So you can say fx is 1, it is a constant function as far as the values are from domain. These are not for every real number. Then students, what about here graph of these kinds of functions? So if I take the graph here, this is our x-axis, origin, and this is our y-axis, and you got fx is 1, right? So this is our f of x value is 1. Now if I draw like this, it is completely a blunder. The reason is whenever I am drawing continuously, the meaning is what here, x is 0, it exists, x equal to, suppose if I take pi by 2, then for pi by 2 also it exists, understand. And if I take 3 pi by 2, then for 3 pi by 2 also you are deciding the answer is here 1. But you can observe clearly for pi by 2 it cannot be 1. For 3 pi by 2 it cannot be 1. And if you come this side, for minus pi by 2 it cannot be 1. you are deleting all odd multiples of pi by 2. Therefore students, you have to take here, this is not there, implies I have to take here a circle. Whenever in any graph, if you are not involving some points from the domain, at that case exactly you have to put a circle. This indicates that you are not taking which value here, pi by 2. Again the other value we are not taking here 3 pi by 2, right? And next here you are not taking minus pi by 2. Understand? So in this way you are deleting here some kinds of values. Again if I take here 5 pi by 2, then here also students you can observe this value here, it is how much? Again a circle. So in this way if you observe how is the graph, the graph is nothing but straight lines, they are coming in this way. Understand students? So now it is clearly representing same kind of values in regular intervals, no doubt, right? And then easily you can decide here about fundamental period. Because of what reason? The shape I can consider single horizontal lines. This is one, this is one, this is one, etc. So single horizontal lines if you take, this is one of the shapes in a regular interval. What is the interval? Minus 90 to 90 implies 180 degrees. Again from this one, this interval 3 pi by 2 minus pi by 2, pi, it is again 180 degrees. Again here also 180. So in a gap of 180 degrees exactly you are observing the values are remaining, the shape of the graph is same. And suppose you may think that I want to take these two as one kind of shape and this is another kind of shape, 2 2 if you take, then what? So you can consider here the fundamental period as how much? Pi, whereas the period it can be 2 pi because you are taking here two horizontal lines as one shape, two horizontal lines another shape, like that it can be 2 pi. In the same way you can proceed even for 3 pi, 4 pi, etc. also. So students, what I want to tell you is, it is a constant function, no doubt, but the constant function is not defined for all the real numbers. It is defined only in a restricted domain, that is this kind of value. Therefore in gaps if you observe, this is actually our shape. Hence we can decide here in this problem fundamental period also exists, and that is nothing but how much here? It is pi. Okay, and let's take another example. That means the example you take, suppose f of x is equal to, I am taking cot pi x into tan pi x. Understand? So suppose you take here f of x is equal to cot pi x and into this is tan pi x. Got students? So this is the value you got. Now what is x coefficient here? This is 5. Okay, here also 5. So if you take this value as our function, then you know clearly these two values are one and the same. Hence it is of the form cot theta into tan theta is 1. So clearly you know this value is how much? Fx is 1. Again you have to check about the proper domain. What is domain? As long as sine function, cosine function are coming, nothing to worry, directly you can put constant for every real number. Whereas when cot, tan they are coming, though there is no denominator seems to be, but those denominators are hiding in these two values. What are those actually here? Cos pi x divided by how much? This is sin pi x, right? This is our cot value. And what is the tan value? Tan value is nothing but sin pi x divided by cos pi x. Then you may think, then what is the problem? Just cancel. But once you are writing any function in this way, then you have to check for what values of x as it is. Without simplification, the particular function can take real values. Understand? So as it is, whenever you are talking about domain, it has to be taken as it is, not after simplification. Understand students? So therefore this function answer is 1, no doubt at all, but not for every real number. Understand? So what about here? Our restriction. The restriction is the denominator part, that is product is here. So the denominator part must be not equal to 0. So what is the denominator part here? It is sin pi x and into cos pi x, right? This value not equal to 0. And you know clearly students, this is of the form sin A cos A. Understand what is formula for sin A cos A? From concept of multiple and submultiple angles, this is half sin 2a. Okay, so therefore here 2a means 2 pi x. This value not equal to 0. Anyhow, half not equal to 0, therefore sin 2 pi x not equal to 0. Implies 2 pi x not equal to what here? N pi. Because earlier we have observed sin theta 0 implies theta equal to n pi. Understand? So in that way we are writing sin 2 pi x not equal to 0 implies 2 pi x shouldn't be here n pi. So what is our concept students here? Sin theta equal to 0 implies theta is n pi. And the other concept sin 2a or half sin 2a, this is equal to sin a cos a, right? So these two formulae, whatever we have applied in earlier concepts, we applied here. Now if you cancel pi and pi, then x not equal to how much here? N by 2, where n is integer. Got it? That means this value, no doubt it is 1, but not for every real number. It is true for all x. Understand? All x which are not equal to how much? N by 2. That means all the real numbers you can take except which kind of values? N by 2. So r minus how much? N by 2, where n is here integer. That means 0 also there, negative numbers as well as positive numbers. Then now what about here? Period of this particular function. Let's make use of again graph. It is very easy because it is y equal to 1. Y equal to 1 students here. Now clearly first I am drawing like this. This is our y equal to 1 graph, right? And now this is our x-axis. This is horizon. So in this way first we have taken. But again, just like our previous problem, wherever here all real numbers are taking, then the line can be here without any gaps you can draw. But here the gaps you are observing n by 2. Understand? One n value if I take 0, that means 0 we have to here delete. So you cannot consider here 0. Understand? That means this value is not there. And next value, n is 1 if I put 1 by 2. Therefore add x is, suppose if I write 1 by 2, then exactly when x is 1 by 2, this is not defined. So that means here also 0. So understand here whatever 0 I am putting, the indication is in whole graph you are not taking this particular x value. This particular x value. Okay. And next value, what is the other one? It is 1. And therefore again you don't take this kind of value. Got it? And next one, 3 by 2. Now again here gap is there. Understand? Now in the same way if you come this side, minus 1 by 2. And therefore here again a circle. Understand students? Then what about period of this function? The period is, that means fundamental period. You are getting again like this lines. Understand? Horizontal lines you are getting which are having same shape. That means they are taking same values in regular intervals. So what is the interval here? 1 by 2. And what about the interval here? 1 minus 1 by 2. That is 1 by 2. And what about here? 3 by 2 minus 1. That is 1 by 2. Therefore, in regular intervals, it is taking same kind of value. Hence, in this problem, you can define again the fundamental period. What is the fundamental period, students, here? It is nothing but exactly 1 by 2. And then period can be multiples of, integral multiples of 1 by 2. It can be 1, it can be 2, it can be 3, like that you can use. But fundamental period here you can define, and that is nothing but how much to this problem? 1 by 2. So students, to this problem period is nothing but how much? So period of, in this problem, cot pi x and into tan pi x is nothing but how much here? It is 1 by 2. Got it? So in this way, constant functions immediately we cannot conclude they are not having, that means the fundamental period is indeterminate. Understand? So you have to take care of every time the domain of that particular constant function. Basing on that particular domain only, you can decide whether fundamental period is indeterminate or else you can write this kind of values. Okay. Now students, observe, yesterday in previous session we have observed a concept, that is if a function f of x is periodic. Okay, if a function f of x is periodic with fundamental period is t. Okay, then we have observed 1 by f of x and its value f of x plus k, or it is k times f of x, or it is here f of x plus k. Understand? Wherever there is no change in x values. Understand? Then the period we have defined, again it is t itself. So here you are multiplying by a scalar value, that is a real number which can be 0 here, not 0. And here also it is k and here k, and everywhere you observe same x is repeating. You are not changing anywhere the x value. Okay. And the next one, the other one we observed f of ax plus b period. Okay, period of this function we have defined period of f of x divided by mod a. So these we have observed individually. Understand? Individually only one function. Whereas if you observe students about this one, here f I x, that means instead of writing f1, f2, f3, f4, simply we can represent like this. So f1x, f2x, f3 and f4, if those functions are first of all periodic, understand, they must have some period. Then the period of g of x, that means other function which is linear combination of these kind of values. So whenever you write in this way, these are said to be linear combination. Here C1, C2, C3, C4, these are constant values and they can be negative or they can be here positive. And as usual, the denominator value always not equal to 0. Then only we can say g of x is a real valued function. So once students, if these conditions are there applicable, that means each of these fi they must have period, and at the same time C1, C2, C3, C4, these are real constants and the denominator not equal to 0. Under these conditions, if at all you want to define about period of g of x, then the period is nothing but you have to consider individually period of each function. Understand? Individually period of each function, then just take the LCM. So period of g of x is nothing but LCM of periods of how much fix. Understand? That is f1, f2, f3, f4 periods you just find, and however they are in denominator, numerator, nothing will happen, but just individual periods you just get and immediately just take the LCM. Then that is nothing but here the period of g of x. Of course, we expect here, as you are considering everywhere the fundamental period, here also we expect here fundamental period. Whatever the answer you got, it can be a fundamental period. But you have to understand, students, whatever the answer you got, it may or may not be fundamental period. That is, which may or may not be the fundamental period, whatever the concept you are using. Let us take here one example. Now, first I am taking the example as here. This is g of x, or some function we are defining as cos 2x, and plus this is suppose cos 3x, right? And in this way you are having. Then individual periods I have to find. What is period of this function? Actually 2 pi divided by 2. Understand? This concept we have discussed in previous session. Period of f of ax plus b is period of f of x, that is without this one a value divided by mod a, that x coefficient. Understand? Now in that way 2 pi is period of cos function divided by the x coefficient is here 2. Therefore 2 pi by 2, and this is how much, students? Pi. And next value, if I write this one, 2 pi divided by 3. So you know this is 120 degrees and this is 180 degrees. Then what is the LCM for 120 degrees and 180 degrees? The LCM obviously it is 360 degrees. That means 2 pi. Understand? Therefore, to this function 2 pi is nothing but what actually? The fundamental period. And if at all you want to check, maybe it is pi, understand, or it may be 3 pi by 2 or any other value, it won't hold good. You can check whenever you want to get here, this is our answer we got. And if at all you want to check, suppose pi hold good or not. Understand, if I write g of x plus pi instead of 2 pi, for fundamental period we are checking the lesser possible values. I am not taking here odd multiples of pi by 2. The reason is immediately function will change. So now if I write this is cos 2 into x plus pi and plus cos 3 into x plus pi. Got it? And now once you got like this, then 2 pi plus 2x, of course you will get again cos 2x, whereas here 3 pi plus 3x. That means it fall in third quadrant, thereby your answer will be how much here? Cos 3x minus. Now this is not our existing g of x, right? So here only 2 pi is our fundamental period, which we got directly from this concept, that is LCM of individual periods. Then another function I am taking, suppose f of x is equal to sin of x minus a divided by cos x. Got it, students? So another function I am taking. Now according as this definition, understand, according as this definition, let us take here the individual periods. This is one function in numerator, this is another one in denominator, which is of this form. Don't understand, there must be always in numerator 2 functions. There must be always in denominator 2 functions. There can be n number of functions in numerator, n number of functions in denominator, or denominator may miss like this. That means in denominator you are having only one. But it should be expressed as sum of functions are here. In this way the fraction. Got, students? So it need not be only 2 functions in numerator, 2 functions in denominator. This can be done even for finite number of values. Total denominator can be 1. Anyways you can use, but it must be here linear combination. So now here if you observe this one, what about period of this numerator, that is one of the functions. If I take this is of the form f1x divided by f2x, right? So now it is actually, if I take 1 into f1x and plus 0 into some other function divided by, like this also you can treat. Now what about here individual period? Period of sin of x minus a. What is this value? The x coefficient you observe, it is 1. Therefore, it is a period of sine function, that is nothing but 2 pi. Okay. And next one, period of cos x. What about this value? This is also here 2 pi. Then what is the LCM of here? 2 pi comma 2 pi, it is again 2 pi only. Got it? Therefore, you got, basing on this kind of definition, the period of this function is nothing but how much? 2 pi. Okay, students, now we decided basing on this the answer is 2 pi. But I am taking here other procedure also, because I want to prove this one. It may or may not be always fundamental period. So now you know about from compound angles this expansion. Then this is nothing but sin x cos a minus how much? Cos x sin a, right? And whole divided by the denominator is cos x. Got it? What we have used from compound angle, the definition. And now I am splitting the function. That means the fraction just split. Then a minus b divided by c means it is a by c minus b by c. Okay, like that we are splitting. Then what will happen here? It is coming as sin x cos a and divided by cos x. After that minus cos x sin a divided by how much it is? Cos x. Now these two you cancel here, students. Then What about the value here? This is sin by cos means tan x, and into how much this is cos a minus what? Sin a. Got it? Now, what about period of this value? Understand? Period of this value is nothing but how much? It is pi. It is a constant independent of x. This is a constant. Whenever you observe sin cos, don't take this a also variable. The problem is x you are representing. When you are representing a function of x, then these a values you have to understand they are constant values. Suppose if I treat this as f of a, then x is constant, a is our variable. That is the indication which value you have to take constant and which value is variable. So whenever I write f of x, then you should understand as long as x is here, only x values are variables. Whatever other than those, you have to treat them those constants. Don't think sin cos means always they are here variable terms. So this is important. Now, according as function of x, as these are constant terms, then period of fx is nothing but how much, students? It is pi. So period you got how much here? It is pi. Whereas using the concept of LCM, you got how much to the same problem? 2 pi. That's why they are telling in the beginning itself, you have to use this formula, no other alternative way. But whenever simplification is possible, better do the simplification part also, so that you can decide exactly which is the fundamental period. So students, you may think that how we can get, that means how we can get the idea, we may get confusion. So if I use this formula, I may or may not get here the fundamental period, then what to do? Clear hint is our options only. Options they give here, A is 2 pi, B is pi, C is suppose 3 pi, and the other option is given as here pi by 2. Got students? Now, according as your formula, that is by taking LCM of individual periods, you got the answer as how much here? 2 pi, no doubt. But once options, in options, if they mention about some lesser values, whatever you got already, better than that lesser values are there, just have a glance whether it is possible or not. Understand, sin of x minus a and divided by cos x. Anyhow, this is not possible even though lesser value, because if I put here cos 90 plus x, it will become minus sin. Therefore, this is anyhow not possible. Therefore, you have to observe whether it is possible or not. It will go very less time. If I take this is suppose the f of x, what you have to take? F of x plus pi. That is the least value, and you replace just x by x plus pi. Then this is sin of x plus pi minus a, and this one is cos of how much? Pi plus x, right? Or x plus pi. Then how we have to write the numerator value? It is a sin of pi plus x minus a. Okay. The known value, we know about sin of pi plus theta like that. That's why these kind of values always you write in the beginning. And the denominator as usual pi plus x, right? Now, what about the numerator? Pi plus means it comes under third quadrant, therefore minus sin of x minus a. And what about denominator? Minus cos x. So you got again which value? F of x. If you replace x by x plus pi, you got again f of x. So students, as you write exam next year or after next year, that means you have lot of time. Meanwhile, you learn many kinds of formulae and your hand will go very fast and your mind also will go very fast. Therefore, nothing to worry how I can decide etc. In the beginning itself, don't think in that way. Okay, so you can get very easily just by observation you can decide. Still lesser value also possible. Okay students, now to find, that means what we understood from this concept, actually we no other alternative. In the beginning we have to go accordingly LCM of all individual periods, but once you observe options, just have a glance whether still lesser values are possible or not. Okay, some problems are with that twist type. And how to find actually LCM. Okay, now all of you are aware of LCM of real numbers. What is LCM of actually real numbers? You know the concept, but that LCM, whatever three real numbers are, finite number of real numbers given, not possible always. Let us check here. Suppose P and Q are real numbers. Understand? If you are taking P and Q are real numbers, then if you get P by Q, understand, always rational, then only LCM of those two numbers exist. Understand? So whenever some real numbers are there, then if at all you got P by Q is a rational number, then only we can decide that kind of LCM is only existing. Suppose I am taking root 2, comma 3 root 2. Got it? And this is your P, this is your Q. Then what about P by Q, students? Here it is 1 divided by 3. Understand? That means you got a rational number. Implies here LCM can exist, and that LCM is nothing but here 3 root 2 value. If you find, you can write. And suppose if I write this is root 2 and this one is root 3. Okay, this is our P and this is our Q. Then what about here P by Q? This P by Q is root 2 divided by root 3. Can we say this is rational? No, obviously it is an irrational number. So here LCM of these kind of numbers, they do not exist. And next other value if I write, suppose one is 5, the other is root 3. Understand? This is your P and this is your Q. Then what about here case 5 divided by root 3? Again it is not a rational number. Understand? Now suppose if I take 2 here, 5 here, then you can say 2 by 5, which is rational. Therefore here LCM exists. So what are our observations from these kind of examples? So whenever you take two real numbers, then P by Q, suppose you got rational number, then clearly you can say LCM of P and Q exists. Understand? I am not telling P by Q is the LCM. P by Q, if it is rational, then LCM of these two numbers exist. Now students, root 2, 3 root 2. What kind of irrational numbers? So these are irrational values, but the LCM can exist here. The reason is you got the value P by Q as rational number. So we have to understand, as long as they are having same kind of, that means irrational value, then obviously the LCM value exists. That means these are known as actually like sorts. Understand? So whenever like sorts exist, that means pi, 2 pi, 3 pi. All of you know very well pi is an irrational number. So for all these, actually these are known as here like sorts. That means same irrational value multiplied by some other value. Suppose if I take root 2 divided by 2 and root 2 divided by 3, root 2 divided by 5. Now observe here all these irrational values multiplied by some other values, that means integers are rational numbers. Now these are known as here like sorts. Understand? Therefore for like sorts LCM exists. So like sorts, students, we call these as like sorts or like irrational numbers here. Here LCM exists. Understand? And next value, if I observe this one, these are unlike sorts. Unlike means this is root 2 and this is root 3 different. So if you have root 2 and 3 root 3 and 5 root 2, then you cannot write here LCM. Though these two are here like sorts, but you cannot write here LCM. So here also LCM does not exist. The reason is what here? These are unlike sorts. Therefore for unlike sorts LCM does not exist. Understand? So here LCM does not exist. So these points are very important, students, while writing the numbers. So they are very easy. You can say, okay, real numbers LCM, I know the concept very well, but these are here very important. So unlike sorts, LCM here does not exist. And this is our example. And now you observe here, one is rational number, one is irrational number. Then also LCM does not exist. So rational number combinations are there in problem, irrational number combinations are there in problem. Then also LCM does not exist. Understand? Now both are rational numbers. Both are rational numbers or all are rational here, then LCM can exist. Understand? So here exist. Now you have to observe the difference while taking LCM. Must be cautious about zero value also. That's why students, so you have to take care of all these to find LCM of these individual periods. Understand? And now how to find actually when fractions are there? Of course, when 2, 3, 4, you know LCM of 2, 3, 4, how much here? It is nothing but obviously the multiple, it is 24, or simply we can say here it is 12, right? But if they ask about LCM of sum A by B, comma, it is C by D, comma, E by F, understand? In this way, fractions are there. Then what is the formula? All of you know in your school you wrote very well. It is nothing but here LCM of all numerator values, that is A, C, E divided by GCD of how much here? The denominator B, D, F. Easy to remember is just LG. LG is a very known name, na? So you can remember LG, LCM of numerator values and GCD of denominator values. So basing on this now we can solve here problems whenever they are this type. Okay.